This episode on periodic table of elements we are recording on the day of Republic Days. So happy Republic Day to all of you. This episode on periodic table of elements is basically for 9th 10th class students, means school level students, to provide chemistry knowledge of periodic table of elements. There are more than 115 elements have been discovered which need to be arranged systematically. First, elements were classified as metals and non-metals. History of classification of elements is as follows. Prouts hypothesis given in 1815. Dobereiners triad in 1829. Newlands law of octaves in 1863. Lother Meyer's curves in 1869. Mendeleev's periodic table in 1869. Modern periodic law of Moseley in 1913. Modern periodic table of 18 columns. Prouts hypothesis. According to this hypothesis, atomic mass of element is multiple of mass of hydrogen atom. So elements are related to each other on the basis of their atomic masses. It fails due to reason that some elements do not have atomic mass in whole number, like chlorine have atomic masses of 35.5. Then comes Dobernier, that is Dobernier's triads. According to Dobernier's triad, elements arranged in the group of three elements so that atomic masses of central element is appropriate mean of first and third elements. These group of three elements are known as Dobernier's triads. Example: Li, Na and K, lithium, sodium, potassium. Atomic mass of lithium 7, sodium 23 and potassium 39. Mean of atomic masses of first and third element is 7 plus 39 divided by 2 is equal to 46 divided by 2 is equal to 23. Drawback of Dobernier's triads: all elements are not arranged in triads. Newlands law of octaves. According to Newlands law of octaves, elements arranged in the group of 8 elements and every 8th element is similar to the first element. Example: lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. Then another group: sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine. Drawbacks of Newlands law of octaves: heavy elements do not follow this law. Inert gases disturb the order of octaves. Then comes Lother Meyer's curves. In 1869, Lother Meyer derived following conclusion by obtaining information from graph between the atomic weight at x-axis and atomic volume at y-axis. Elements which have similar properties found on the same position on the graph curves. All alkali metals like lithium, sodium, potassium, rubidium, cesium, francium found at highest peak of curves. Halogens like fluorine, chlorine, bromine and iodine are found on ascending portion of curves. Alkaline earth metals like magnesium, calcium, strontium, barium, rhodium are found on descending portion of curves. Elements which do not melt easily like beryllium, boron, carbon, aluminium, silicon, copper, etc. are found at lowest point of curves. On the basis of above conclusion, Lother Meyer give periodic table. Periodic law. According to Lother Meyer periodic law, atomic volume of elements are periodic function of their atomic weights. Then comes periodic table. To classify elements, a chart is prepared in which elements are arranged in rows and columns. These elements are arranged in table in such a way that the elements with similar properties are repeated after some intervals. Also, elements with similar properties are put in the same column below one another. In periodic table, vertical columns are called groups, while horizontal rows are called periods. In periodic table, this repetition of properties in regular interval is known as periodicity. Given below are in our discussion is Mendeleev's periodic table, Moseley's periodic table, modern periodic table. First, Mendeleev's periodic table. In Mendeleev's periodic table, Mendeleev classified elements according to their atomic masses and arranged these elements in periodic table according to their increasing order of atomic masses. Mendeleev's periodic law. According to Mendeleev's periodic law, physical and chemical properties of elements are periodic function of their atomic masses. Mendeleev's periodic table contains 7 horizontal rows known as periods and 9 vertical columns known as groups. Group of Mendeleev's periodic table. In original Mendeleev's periodic table, only 8 groups present because 0 group contains noble gases is added later after discovery of noble gases. So total vertical columns is 9 including group 1 to 8 and 0 group. Group 1 to 7 are divided into subgroups A and B each. In 8th group, 3 elements found together in each period from 4th period onwards, known as transition triplet. Periods of Mendeleev's periodic table. Mendeleev's periodic table has 7 periods. First period is known as very short period because contains only 2 elements. Second and third period is known as short period because contain only 8 elements each. Fourth and fifth period is known as long period because contain 18 elements each. Sixth period is known as very long period because contain 32 elements each, 18 elements in table and remaining 14 elements called lanthanides from atomic number 58 to 71. Seventh period is known as incomplete period because it contains only 24 elements and some places are left vacant for elements as they are not known yet. 10 elements in the table and remaining 14 elements called as actinides from atomic number 90 to 103 placed outside at bottom of periodic table. Demerits of Mendeleev's periodic table. These below points are some demerits of Mendeleev periodic table. First, position of hydrogen. Hydrogen is placed in first as well as in 7th group because its properties are similar to both groups, which is not explained well. Elements which have similar properties are placed apart in different groups. Example, copper and mercury with similar properties placed in group first and second. Elements with different properties are placed in one group. Example, coin metals like lithium, sodium, potassium, rubidium, cesium. Atomic weights are not kept in serial order. Example, argon with higher atomic weight 39.948 is placed before potassium which have lower atomic weight 39.102. Position of isotope is not proper because all isotopes of elements are placed in one group, though the atomic weights of isotope are different. Eighth group, elements. Position is not appropriate because elements put in triplet form. Rare earth elements, lanthanides and actinides. Position is not proper so they placed outside at bottom of periodic table. Modern periodic law and modern periodic table comes in role after that. That is Moseley in 1913, after doing many experiments, comes to a conclusion that the elements should be arranged as per their atomic number and not according to atomic masses, as atomic number is fundamental property of all elements of periodic table. So Moseley gives a new law which is called modern periodic law. Modern periodic law. According to modern periodic law, physical and chemical properties of elements are periodic function of their atomic numbers. This law is given by Moseley. Long form of periodic table. Bohr invented new periodic table which is called as long form of periodic table. This long form of periodic table is also known as modern periodic table. Special feature of modern or long form of periodic table. These below are special features of modern or long form of periodic table. 18 vertical columns known as groups, horizontal rows known as periods. Light metals, these are elements of periodic table of group 1 and 2. Heavy metals or transition metals, these are elements of periodic table of group 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. That is 3 to 12. Non-metals, these are group 13, 14, 15, 16 and 17. That is 13 to 17. Zero group, these are elements of periodic table of group 18. Properties of periods. All periods start with alkali metals and end with noble gases. If we see table, it is very clear that from first to seventh period there is an addition of one cell in the each period, like n is equal to 1, 2, 3, 4, 5, so on. Properties of groups. In any group, outermost cell electron are known as valence electrons, and these electrons are same, so main properties of elements of group is similar. Elements are divided into four blocks, which is S, P, D, F according to valence electrons. S block elements of group first and second. P block elements of group 13 to group 18. D block elements of group 3 to 12. F block elements of the lanthanide and actinide series. Representative elements of S block and P block elements are collectively called as representative elements, also known as normal elements or typical elements. Transition elements of D block are called as transition elements. Inner transition elements of F block are known as rare earth elements or inner transition elements. Alkali metals, elements of first group, are known as alkali metals. Alkaline earth metals, elements of second group, are known as alkaline earth metals. Solution for the demerits of Mendeleev's periodic table in the long form of periodic table or modern periodic tables. Mendeleev's periodic table contains some heavy elements placed before lighter elements. This problem is solved automatically in modern periodic table. All isotopes of an element have same atomic number, so no need to place them separate. All inert gases or noble gases got their appropriate place in 0 group or 18th group. Mendeleev periodic table have problem with 8th group, but it is resolved in modern periodic table as it is divided into three groups. Drawbacks of modern periodic table. Position of hydrogen is still not clear in modern periodic table. Position of F block elements, lanthanide and actinides, is not proper as these placed at bottom separately from periodic table, that is impractical. Periodic properties of the elements. Periodic properties are the properties of the elements which depends on their electronic configuration, and these properties change on moving down in the group and on moving left to right in the period of the periodic table. Some periodic properties are atomic size, electron affinity, ionization energy, metallic and non-metallic properties, etc. are the main periodic properties. Atomic size. Size of any atom is explained with the help of atomic radius. Atomic radius. The distance between outermost shell electrons and center of nucleus of isolated atom is called atomic radius. There are two hypotheses for the calculation of atomic radius, that is van der Waals radius or covalent radius. Van der Waals radius. It is the one half of the distance between the two adjacent atoms nuclei centers is known as van der Waals radii. Van der Waals radii is calculated as follows. First, calculate the distance from the center of nuclei of one atom to the center of nuclei of another adjacent atom in solid state of same substance. Then divide this distance by 2. Van der Waals distance is represented by angstrom A, where 1 angstrom is equal to 10 to power minus 8 centimeter. Covalent radii. It is the one half of the distance between the diatomic molecules nuclide centers is known as covalent radii. Covalent radii is calculated as follows. First, calculate the distance from the center of nuclei of one atom to center of nuclei of another atom in diatomic molecule containing covalent single bond. Then divide this distance by 2. Isolated atom. Isolated atom is an absolutely alone single atom. Periodicity in atomic size. In periods, on moving left to right in any period, atomic size decreases because atomic radii decreases as electrons are attracted towards nucleus due to increasing nuclear charge. In group, on moving down in any group, atomic size increases because atomic radii increases as more electron cells added. An ionic radii of cation is smaller than its normal atom, while that of anion is larger than its normal atom. Cations are formed by loss of electron or electrons and carry positive charge. Anions are formed by gain of electrons or electrons and carry negative charge. Ionization energy. The energy required for the removal of one electron from the isolated atom in gaseous state is called ionization energy. Ionization energy is represented by I dot E dot. Ionization energy is expressed in electron volts per atom or kilojoules per mole or kilocalories per mole. Ionization energy is also known as ionization potential. Equation for I dot E means ionization energy. Atom in gaseous state plus ionization energy gives cation plus electron. Removal of further electron from cation is difficult, so value of ionization energy kept on increasing. IE1 is smaller than IE2 is smaller than IE3 is smaller than IE4, means ionization energy increases with removal of electron, means it is more difficult to remove more electron from a cation. Periodicity in ionization energy. In periods on moving left to right in any period, ionization energy increases because nuclear charge increases with increasing atomic number. So more energy required to remove electron. Therefore, value of ionization energy increases on moving left to right in any period. In group, on moving down in any group, ionization energy decreases because atomic size increases as more electron cells added. Electron affinity. The amount of energy released as a result of addition of electron in any atom in gaseous state to form anion is known as electron affinity. Electron affinity is represented by E dot A dot. Electron affinity is expressed in electron volts per mole or kilojoule per mole. Values of all electron affinities are negative except first electron affinity, which is positive. Periodicity in electron affinity. In period, on moving left to right in any period, the value of electron affinity increases because atomic size decreases. So, amount of energy released is more. In group, on moving down in any group, the value of electron affinity decreases with some irregularities. Metallic and non-metallic characters. In periods, on moving left to right in any period, metallic character decreases and non-metallic character increases. In group, on moving down in any group, metallic character increases and non-metallic character decreases. In periodic table, metallic elements are found on left hand side and non-metallic elements are found on right hand side. Metalloids. The elements which are neither metals and nor non-metals are known as metalloids. Example of metalloids: boron, silicon, arsenic, etc. You listen this episodes on Chemistry Notes Info channel. Visit our website www.chemistrynotesinfo.com to learn more about chemistry. Thank you to listening.